All right, so let's look at number 4 on the 2018 AP Chemistry free response. This is the first of the smaller questions. Usually, it definitely will only be 4 points. A is going to be worth 2 points. B is going to be worth 2 points. It's usually how it goes. Sometimes it might be 1 point and 3 if like B was a lot bigger than A, and, so to speak, it just covered a lot more material. So here we go. If you have not done this, maybe pause the video, return after you have, check your answers, see the point distribution. A, in terms of types and relative strengths of all the intermolecular forces in each compound, explain why the boiling point of CS2 is higher than that of COS. So CS2 boils at 319 Kelvin, COS boils at 223 Kelvin. So we start thinking about intermolecular forces and we start thinking about boiling point. And we remember the higher the boiling point, either you have more intermolecular forces or something about this one's intermolecular forces is just way stronger, way more effective, so to speak, than those of COS. So we need to try to figure out what that is. We are given a representation of their molecular structure right here. But real quick, let's just remind ourselves. So CS2, that would be 4 plus 6 times 2. So we would be looking at 16 valence electrons. We'll just do the Lewis structures real quick. Carbon's always in the middle. We always start with single bonds to our terminal atoms. That's 4 electrons, 12 remain. Make the terminal or outside atoms happy, so to speak, meaning make sure they have their octet first. And we're out of electrons. That is 16 electrons. But when we check our answer, the sulfurs have an octet, but the carbon doesn't. So we think back to CNOPS, which is not perfect. There are other elements that can double or triple bond, but these are the elements that most commonly double or triple bond with themselves or each other. Since carbon and sulfur are both present, we know with absolute certainty that we can remove a lone pair, make a double bond, remove a lone pair, make a double bond. It is still 16 electrons. Now the sulfurs and the carbon are all surrounded by octets. So that's our Lewis structure. COS is the exact same count. It ends up in the exact same situation. Carbon, sulfur, and oxygen are in CNOP, so we can make double bonds right there. So this is our Lewis structure. So for the intermolecular forces, well, everybody that has electrons has LDF, or London dispersion forces, due to the movement of the electrons making a temporary dipole and inducing a dipole in a neighbor. None of these can hydrogen bond. That's silly. They don't have hydrogen directly bonded to nitrogen, oxygen, or fluorine. So now we have a polar bond and a polar bond, but due to the shape, it's linear. It's a 180-degree bond angle. And the fact that the bonds are the same polarity, this is a non-polar molecule. So this cannot dipole-dipole. Remember, a lot of students remember that as polar-polar. You have to be a polar molecule to be able to dipole-dipole. Well, even though there are polar bonds, as far as the molecule is concerned, they cancel each other out. All this has is LDF. Down here, we know we have LDF, no hydrogen bonding. We have a polar bond and a polar bond, but even though this is linear, 180-degree bond angle, carbon-sulfur polarity is different than the carbon-oxygen polarity of these bonds. Due to the imbalance, they cannot cancel each other. So this also has dipole-dipole. But the question said that CS2 had the higher boiling point. So this is, what you might call a discrepant event, even though COS has more intermolecular forces than CS2, its boiling point is lower than that of CS2. So the question wanted us to explain this. So our answer could say that CS2 only has LDF, COS has LDF and dipole-dipole. Correctly identifying the intermolecular forces was worth 1 point. And then saying apparently, since the boiling point of CS2 is higher than that of COS, the London dispersion force of CS2 is greater than the combination of the London dispersion force and dipole-dipole of COS, therefore it has a higher boiling point. So that was an explanation that described that apparently the LDF of CS2 is greater than the combination of LDF and dipole-dipole for COS. That merited the second point in number 1. So number 4A. In 4B, a 10-gram sample is put in a 5-liter rigid container that's empty. It is sealed and heated to 325 Kelvin, at which point all of the original liquid reactant has vaporized. What is the pressure once all this is vaporized? And we start looking around and going, well, hey, I have volume and I have temperature and I've been given a mass, so this looks like a very good opportunity to trot out the ideal gas law, PV equals nRT. Some students like to remember it as PERV-NERT. And we can use this to solve for the pressure. And as always, when in doubt, find the mole. If we add up carbon and 2 sulfurs, the molar mass is 76.13 grams per mole. So 10 grams of CS2. You always want to write that down. You always want to show your work. Divided by 76.13 grams per mole. So we'll do this in our calculator. So 10 divided by 76.13. And it's a little hard to see on the calculator the way the lighting is right here. But 0.131 moles of CS2 is what we get. That's what I would write down right here, because we had 3 sig figs and 10.0. I would leave the actual number in the calculator, though, to use, because we really don't want to round a lot before we get to the final answer that the question is seeking. So now, to solve for the pressure, we would take our moles, multiply by the gas constant that is on your equation sheet, as well as the ideal gas law. Always want to show units. And the temperature is already in Kelvin. We don't have to do really any unit changes except for going from gram to mole. And the volume was 5 liters. So note, these were the 3 numbers we were given. 3 sig figs, 2 sig figs, 3 sig figs. 2 sig figs is what we're going to express our answer in. And so if we grab our calculator and we multiply N, R, and T, and we divide by the volume, we get a pressure of 0.70, again, 2 sig figs, atmospheres, have to show that unit, for our answer. It was 1 point for getting the moles of CS2, and the final point, the 4th point in this problem, was getting 0.7 atmospheres for our final answer.